Right, so we're going to start off with tinning. The whole principle of tinning is to make the final connection, your final solder joint, a lot easier. So you should always tin the two things that are going to be soldered together. So it doesn't matter if it's your terminal or the wire. You want to try and tin both of them before you make your connection. You also need to keep your soldering tip tinned, because the key to soldering is heat transfer. So if you're not, if you haven't got a clean, nice and shiny solder tip, you're going to struggle to make a very good joint. So what do I mean by tinning? There's my solder tip, there's my solder. Just giving it a nice coat all the way around, and then wiping off the excess. There you go. Now in terms of tinning your components, you only want a light coat of solder, but I'll show you if I turn it this way. Now this is a standard CTS pot, it's going to be my volume control. So the way I like to do it is to hold my soldering tip behind the terminal that's being tinned and just lightly flow, like you're drawing around the circle, your solder from the other side. And that works because the heat generated, transferred from this tip to there, is hot enough for my solder to melt from the other side. If you're wondering what temperature, bear in mind this is lead-free silver solder. My solder station is set to 395. If you're using leaded, you could get away with, well, as low as 335, 340. So I'm just holding it behind and flowing it on from the other side. There you go. Now if I'm tinning my wire, it's exactly the same principle. I'm just I'm doing this a bit makeshift bodge because I don't have my clamps. So there you go, nicely tinned. You just want to heat the wire and flow a little bit of solder into the stranded core. Now in terms of tinning the back of CTS pots, this is highly recommended because CTS pots, well, not CTS, pots generally require more heat on their back casing than you would do for connecting two wires to terminals, for example. So I'm holding, if I turn it around this way, I'm going to hold my soldering tip onto the required area, let it heat up for a bit, flow in your solder, spread it around a tiny bit. There you go. There's a little puddle of solder there. So when I apply my ground wire, I'm obviously going to put it into that puddle there, and we'll take it from there. And likewise, oh excuse me, if you're doing a switch on a Strat, it's exactly the same principle. Let's see if I can get the camera in. So soldering iron behind the terminal, or the lug, whatever you want to call it, and then flowing my solder from the other side. And flow it on that way. So that's your introduction to tinning. So every time I do a Strat, for example, every time you wire up something, spend a good 5 minutes following your wiring diagram and just start tinning the terminals and the connections that you know are going to need a solder joint, and it just makes it a lot easier. So for now, when I thread my wire through, let's assume this is coming from the pickup. If I thread that in there, turn it around so you get a better view. So that's my braided wire coming from my pickup. Let's call it the neck pickup, and this is the neck control. It literally takes a tiny amount of heat, and you don't have to flow in much solder to complete that connection. There you go. And this is why I have these tiny wires here, wire cutters, just to trim the end. So that's the advantage of tinning.